Welcome to MLOps Live, a podcast by Neptune.ai.
We host in-depth discussions where machine learning practitioners answer questions from other practitioners about one subject related to production machine learning and MLOps.
Tune in to get real-life stories, dirty hacks, and pragmatic workarounds from ML people in the trenches. Hello and welcome to MLOps Live. I'm Sabine and I'm joined as always by my co-host Steven.
Hi, Sabine.
Hi there, and with us today we have Adam Becker and we'll be talking about AutoML and MLOps. Hello, Adam.
Hello, thank you for having me.
Awesome. So Adam, you are the co-founder and head of machine learning at Telepath, right?
That's right, yeah.
And it's a machine learning platform that aims to unlock the power of ML for every developer so they can build smarter and more robust products. And you have some academic background as well, surprisingly. 2 bachelor's degrees from University of California, because why settle with one? As it's really a common pattern to have this, as we already noted last time, to have something like physics. You have astrophysics, correct, as one of yours.
Yeah.
And perhaps more unusually, classical ancient studies. So always kind of like, or commonly a bit of a mixed bag there.
Yeah, I felt like when I started by doing astrophysics in business, and then at some point I kept taking these classics courses, and I was like, nope, this is it. And I kind of went back and forth, and the moment that I dropped one of them. At first, I just did some classics for a little bit. Then I realized I wasn't very good at classics. Then I picked up astrophysics and I realized I'm not very good at astrophysics. But then when I did both of them at the same time, I felt like I was pretty good at both of them. So it's like some parts of the brain were just like they needed to be activated for the full brain to kind of kick in.
Wow. Well, I'm glad you found a path there. So then you got into co-founding companies. Basically. So apart from Telepath, you've co-founded EggStage and CallTime, which is a platform for political fundraising, and it leverages automation, big data, machine learning, and AI. It doesn't stop there. You're also the host of the AutoML podcast, so a seasoned podcaster already, publishing weekly episodes about the science and engineering behind AutoML systems. And you are currently co-organizing the New York City MLOps Community, which has more than 1,000 members. So very prolific MLOps community member.
Yeah, it's been growing incredibly fast. I think we had our first event in April, and we have our next one is tomorrow night with, I think we had to cap it, I think at like 260 RSVPs. This is all just in-person meetups. So it's going to be pretty large. If anybody listening is ever in New York and would like to plug into the community, just Google MLOps NYC and you'll find our meetup.
Awesome. Yeah, any New York listeners, make sure to make a note of that. So a bit of housekeeping before we get into the questions here, Adam. So just a reminder, this is going to be released as a podcast later on in a couple of weeks, once all the editing and magic has been done. And this is a totally interactive Q&A session. So all you need to do if you're present here live with us is you can raise your hand. We will unmute you and you can ask your question from Adam right here. You can also type your question in chat, of course, and we will pick it up at a suitable time. So to warm Adam up here, how would you explain to us AutoML and how it relates to MLOps in 1 minute?
1 minute, okay. I think that the way I see AutoML is it's just any non-human method to improve the modeling process. And some of those methods are already quite ubiquitous. So think about, let's say, hyperparameter optimization. Right, like nobody goes and does manual tuning of the hyperparameters for their models, right? Like you just use some existing packages, or you do a form of grid search, or you do some Bayesian method or random search. There's lots of different techniques. You could continue to just like expand the scope a little bit. So not just hyperparameters. What about your choice of estimator in the first place? Should it be XGBoost or LightGBM, or even your choice of the architecture for a deep learning model? So this is all AutoML, and this is part of AutoML. AutoML can just have an even broader scope. And I think it has a pretty big dream and ambition, AutoML itself. And I think it also it has the capacity to fully realize the dream of MLOps too. So I think that MLOps could become much bigger and more ambitious, and AutoML is one way of getting it there.
Awesome. That was.
How am I doing on time?
It was a little bit over, but we will definitely forgive you. So nice job. All right, Steven, over to you.
All right. Thanks, Adam. And I'm just going to be going through, but we have quite a lot of submitted questions, but I'm going to be going through some of the questions that were premeditated before now. And I know at Telepath, even before Telepath and the company you were with, you worked with automation, as well as you right now in Telepath, you're also working with startups now that are trying to leverage AutoML solutions. And I think one of the pushbacks we see often is that more and more startups are not going towards the path of AutoML. They know they have to deal with a lot of infrastructure problems and everything that has to do with MLOps, right? And even both on the development side and the deployment side. But more and more startups are not looking at that idea of adopting or using the AutoML solutions. Instead, you're hiring in-house CV experts as well as DevOps experts or MLOps engineers to really do that particular move from deployments, move their models from development to deployment. Why are you seeing this sort of trend where startups are not fully realizing the use of AutoML, and even more so how they particularly move things quickly from modeling to production?
Yeah, that's a very good question. So I think to fully answer that question, I need to give a little bit more context about how I see the relationship between MLOps and AutoML.
Right.
So the way that I see it is, I think that MLOps today is solving problems for companies that have already fully adopted what I call the prediction paradigm. They are already familiar with machine learning, and they're bumping into certain obstacles along the path to productionizing those models, right? So they already are thinking in these terms. I believe that that is not actually representative of most of the market. I believe that most companies, certainly most teams, most companies, maybe not most enterprise, but most companies don't even know where to get started with machine learning. They're not having machine learning operationalizing problems. They're not quite there yet. They're still in the domain of thinking that ML is magic, right? And then they are bringing on data scientists and expecting of them to deliver magic. And then they see that that fails. It's because they haven't yet adopted this paradigm. The paradigm, I call this the prediction paradigm, right? Where you have columns of data that essentially are features. They are predictive of another column that is the target column. There's training involved. There's validation involved. There's the choice of metrics. There's retraining. There's drift. The entire scope of what we mean by machine learning today, they haven't yet adopted. And I think that's by and large true. And it's also true for most startups that end with the .ai in their domain name. This is, if you want to find companies that are not doing AI, just look for companies that have a .ai in their domain. Their AI is an aspiration for them, but they're not quite there yet. So most of the companies that you see not adopting AutoML are those companies that have already invested very heavily in setting up massive data teams, right? So we're talking about those companies that are already fully invested in data scientists. That's a very different version than what I have in mind. It's almost a little bit like, if you think about MLOps today is like selling water bottles to people who just finished running a marathon. Of all the people that finished running a marathon, many of them are thirsty. So of course, there's a good market there's demand for, if you finished a marathon, yes, you're gonna be thirsty. But if you look at it, by and large, the race is empty. There's nobody running. I believe that's the situation that we have today, where nobody's even in the running. We have so few companies actually engaged in model building. And I think that AutoML needs to address those folks, not the folks that are already having challenges with productionizing their models.
Right. And brings me to this sort of, because there's always this talk about AutoML and AutoMLOps. So what's your opinion of that AutoML versus AutoMLOps? Because yes, we're at this point where we know that companies are not there yet. That we only have few companies that are actually productionizing MLOps systems. But then you're seeing this promise about automating the MLOps process as well. So what's your take on that for these companies anyways?
I think that it really depends where in the life cycle of their modeling they are. What are the challenges? If the challenges are about getting started, MLOps is not the solution. They don't even have data scientists. They haven't adopted the prediction paradigm. So they need completely different tools. If their challenges are that they have all these models and they don't really even know how to stitch them together and put them in production and retrain and monitor, if that's their problem, then give them whatever automation tool is possible, whether MLOps or not. I think that it's just like these are completely different groups of people. So this is, for example, like when we were doing Call Time, this is our previous company, we were trying to model donor behavior. And it's amazing. I think that there is this curse of knowledge that is bewitching people in our community, which is like the moment you've adopted the prediction paradigm, you understand the world in terms of features and instances and observations and predictive value and all these different things. The moment you see it this way, it's almost like we forgot what it was like not to have seen the world in this way. And we're all just operating under this paradigm. It's almost like, do you know these like images where, I think it's kind of like an optical illusion where if you look at the image, it looks like a face of a human, but if only you focus on if you focus on the right corner, it looks like a dog in a snowy forest or something like that. I think it's like that. Right now, we're just seeing the world in that way, but few companies are actually seeing the world in this way. So I think that the challenge that they have and the challenge that we had is, okay, fine, now you have access to all this data. Fine. Is this a classification problem? Is this a regression problem? Actually, this seems more of like a recommendation system problem. No. Is this a time series problem because there's a temporal component to this? How should you think about your validation? Should you be validating the purchases? Should you hold out the purchases or the users? All of these questions are ones that I think are the ones that actually block companies from adopting machine learning. And I believe that MLOps could produce more features that help to bring more people to the race in the first place. And then they'll have challenges productionizing, and then MLOps can blossom.
Yeah, definitely. Thanks for sharing that, Adam. And another question here is the use cases, because I think most people are this fervently against the pushback against the use of AutoML. But what are those use cases where you see AutoML thrive a lot in? Like, for sure, you can properly model your requirements as a data scientist, or maybe you're new to the old machine learning paradigm, and then you just want to get something out there quickly. What are those use cases that you've seen that AutoML thrives for particularly well in the modeling space that helps teams move quickly from, having nothing to having a production ready model or something that they can actually deploy?
Yeah, that's a good question. So I probably have a bit of a textured answer for you here. I think that I'm not entirely convinced that data scientists should use AutoML. It's insofar, I think that there are benefits for them to use AutoML. I would say those are, for the most part, marginal benefits. Maybe the benefits might be more in the MLOps aspect of AutoML. Many AutoML platforms can abstract away a lot of the MLOps, so you get a lot of benefits that way. So those could be beneficial. I believe that in the long term, AutoML is very likely to win out against humans, probably any day, right? Like this is in the long term. So I'm not imagining the data scientists will stick around to compete with AutoML models. We're not quite there yet, but we're going to get there soon. At this point, I think if data scientists want to use AutoML, certainly for any tabular data set they want to establish some like excellent benchmarks against, and they have the funding to do it, they could certainly pick that up. And I think that DataRobot has, if you look up DataRobot Pathfinder, they have hundreds of examples of various use cases where it's useful to do that. So I think that if data scientists want to do it, I think it could be useful, if not only for the modeling per se, but in organizing their entire flow and their various experiments. I think that AutoML could be very useful in that way. And also in helping them to come up and to experiment more rapidly with ideas, right? So like, what if I have this column? What if I have that column? What if I have this column? just try out 100 of them at a time and just like push them through some AutoML and you'll be fine.
Yeah, thanks, Adam. And you mentioned earlier that you feel like the AutoML is just a small part of or it's just a part of accelerating the world of MLOps itself. But what are those challenges you see that stop that from happening, especially for teams looking to just use this? So
yeah, I think that there are teams that are not. I think that AutoML today is targeting the wrong audience, or at least it's a relatively small audience. So they're targeting data scientists, and data scientists have almost a vested interest not to adopt AutoML, right? Like they've invested years of their lives in trying to, they can't be seen as now being defeated by an AutoML system, just like an automatic system. That's gotta hurt. So I think that it's a very sort of like natural reason why companies with data scientists would not be quick to adopt AutoML. But if AutoML were to target a slightly different audience, and I think you see that, let's say, with certain companies and products that are targeting, let's say, like the business function, right? Or analysts or folks without modeling experience. I think that could be pretty interesting. I'm not entirely sure the degree to which those people have a mandate to take models and then put them in production or power applications with it. So that's, I think, like, it's potentially questionable in that way. But this is the belief that we have in our company, is that what if you take AutoML and you orient it towards software developers? So companies are already staffed full with software developers, and they're very close to the data, they're very close to the product, they're very close to understanding the user experience. Why not arm them with AutoML? So I think that there's a few challenges. I think that like the main challenge has been that AutoML has not been oriented towards unlocking the big market. And it could also be the case that MLOps platforms are still trying to get a good grip of what to do. So they haven't yet added AutoML functionality into their own platforms. And I believe that that's likely to change in the next few years.
All right, thanks, Adam. So we have a couple of questions from community that we asked in the community. And this person asks from Discord, I'm working on an AutoML project. I want to launch a process for automated model training. I'm interested in how I can monitor the process for resource usage or failures with ready-made APIs. Currently, I'm exploring Airflow and Metaflow. Do you have any suggestion and idea on this?
Yeah, I think that would really depend on the platform in which they're using their AutoML. So the question would be, are you using AutoML, let's say in an out-of-the-box library, and you're running your own process, and you're building your own model, and then you're taking that model and you're deploying it somewhere? In which case, wherever you're deploying it, they'll expose some APIs. If you're on AWS, you'll have to kind of either use the SDK to just pull out the whatever metrics you care about, and then decide how to retrain. If you're using something like SageMaker, that might be a little bit easier, right? You could just like read the SageMaker documentations about retraining, or about metrics for, let's say, like your resource usage. If you're using something like H2O or Data Robot, I imagine that they have a similar kind of flow. But I will make a couple of notes here, because it's retraining in the AutoML context, I think there's an interesting answer here, because it's not entirely clear what that means, retraining. Does that mean that you are relaunching your entire AutoML search? So if you think about AutoML, it's just like a giant search problem, right? So like you're saying, well, I want to find an estimator, and maybe I want to find a preprocessor, and I want to do some feature selection, and I want to tune all the hyperparameters. There's so many different options of what you could do, right? So the goal of an AutoML system is to efficiently travel through all of those options, navigate through this massive landscape of options until you find the most promising pipeline or workflow or estimator or set of hyperparameters, depending on what your AutoML task is. So when you say retraining, should you retrain as in restart that entire search problem? Should you retrain so that you're only learning incrementally on the newest data? Should you retrain as in you should take the exact same model or pipeline that won out in the AutoML contest and retrain that one? So you have a few different options here. And what I hope is that AutoML platforms would give you that out of the box. They would tell you what kind of retraining is necessary, because some retraining is more expensive than others. So for example, this is one of the things that we're going to be building, is some of that kind of logic in-house. But short of that, you might have to kind of do your own analysis to figure out what is the style of retraining that you should subject yourself to, and also what the frequency is, right? If you have to do this every day, maybe it makes no sense for you to restart your entire search process.
Yeah, I think the model retraining aspect is a crucial part of people figuring out whether they should think about this. But I think this person was asking particularly about the training itself. And we have another question, and this person is asking, I'm interested in knowing your experience working like for an AutoML startup. What's your take on the maturity of the technology? Do you think it's ready for prime time, or are there still major gaps that needs to be bridged?
I think that currently the most important thing that this could do for us and for the space is to help people climb over that prediction paradigm. They need to be able to adopt the prediction paradigm. And I think that AutoML could be very useful in getting us there. Once you get the model out, okay, so let's now distinguish between what like an AutoML platform and AutoML, a model that came out of AutoML. If you're using, let's say, something like AutoScikit-learn or AutoGluon, even like locally, if you manage to get your model out, that's the same model that you would have gotten from a data scientist spending 3 or 4 months on that model, right? So at that point, is that model ready for production? Well, if I handed to you an AutoML generated model or a data scientist generated model, you wouldn't even be able to know the difference, right? So just take that model and continue with your MLOps flow. So I wouldn't say much about the maturity level in the actual productionizing of the model. At that point, the model is the same. What about the maturity level in terms of identifying the right kind of model given the data set, right? Is AutoML better than a human data scientist is today? That I think is a different level of maturity. And I think that the answer is, not surprisingly, it depends. You should certainly try it out on a lot of Kaggle data sets. AutoML is beating human data scientists. For computer vision, it's already producing state-of-the-art, but it might be more expensive. So ultimately, it's going to become much cheaper and much easier to experiment with. But at least for now, on by and large, most tabular data sets that you're likely to come across, certainly if you're a data scientist, you've already pre-processed and somewhat prepared the data set. The model you're going to get back is going to be just ready for production in the same way that the model that you will have generated, if not probably even better and more reliable and better tested.
Yeah, and I see there's been this sort of evolution of the technology, and it's just gone beyond modeling right now. I mean, it's beginning to go beyond modeling, and you started to see things around data processing, automated data processing, feature engineering. And how much are you seeing a maturity in those spaces? Because I think one of the key reasons that we see like teams push back and everything is like, hey, look, I mean, I get to do my feature engineering myself, right? I mean, AutoML can't help with this. You just go straight to modeling, and then it's a bit hard to frame this problem or codify this problem or things like that. How much have you seen the maturity for tools that are bringing about the promise of automating the data processing aspects or feature engineering aspects of the life cycle?
I love this question. This is a great question. So let me tackle it in a few ways. Have you guys heard of the AI effect? I think it's called the AI effect. It's like when something, if you were to tell somebody about AI is able to do this one thing, the moment that it's done, the moment that you've solved it, people no longer think about it as AI. They just think about it as engineering. And it's like, you're always continuing to chase that thing that is called AI. And the moment it's unlocked, you're like, no, that was just a big model. That was just engineering. If you think about a calculator today, right? Like nobody thinks about a calculator as AI, right? But back in the day, you would evaluate somebody's intelligence on the basis of their ability to do arithmetic fast, right? So now you say that is what it means to be intelligent. And well, now a calculator is able to do it. You say, well, that's no longer intelligent. That's just engineering. I think there's probably a similar thing happening with AutoML. People would be skeptical of AutoML, but now they've shifted the goalpost. Now it's about data preprocessing, right? Well, previously it was doing machine learning was about hyperparameter optimization, right? Or algorithm selection. And now we've solved that. So they said, okay, what about the data preprocessing? That's really where. Okay, fine. At some point, we'll solve that too. And then they'll say, no, but it's really about your problem framings. At some point, we'll solve that too. And then they'll say, no, but it really is about the model topology. So first you have this model that feeds into this other model. At some point, we'll solve all of those things. I think that currently AutoML excels with hyperparameter optimization, with algorithm selection, and with various forms of pipeline synthesis and pre-processing. Let me go a little bit deeper into that, because if, for example, you have a choice of algorithm, let's say it's a decision tree. To what extent does it matter that you've, let's say, scaled or standardized your data? It may or may not matter, right? Like an algorithm like that may be scale invariant. So you say, okay, fine, so I don't need that preprocessing. What about imputation? To what extent should you impute your data? Again, that depends on the kind of algorithm that you have downstream. Some algorithms downstream can handle it, and other algorithms can't handle it. So you already see that there is some tight dependence between various types of preprocessing and the ultimate algorithm that you're going to be using as your estimator. So for all of those ones, AutoML is already pretty good. But now as you keep climbing up, you say, what about data representation? Let's say that somebody might consider that data preprocessing. So let's say you have a zip code column. Somebody gives you a zip code column. What do? You're a data scientist. You see this, it looks kind of like numbers, but you're not just going to feed it in as a number, or at least you may or may not, depending on whether or not you've encoded it as to be a string, and you know that the decision tree might parse on it, or maybe you need to do a one-hot encoding, or maybe you need to do a geohash, or maybe a latitude and longitude, or maybe a latitude and longitude and the cosine of both of those. Maybe that's, or maybe you need to do something like the k nearest neighbors in location space, and then pick up and aggregate various attributes of the neighboring instances. There are various approaches for doing that. So that's something that data scientists today are sort of trained to work on, right? And to see the world in that light, and to say, how do I even represent the data in the first place so as to be able to extract the most predictive value out of that data? Because the way it's encoded right now, the algorithms are not going to be able to pick up the predictive juice. So that kind of data representation, AutoML systems are already starting to pick up and starting to adopt. They're not nearly as far as I wish them to be. This is one of the things that we're working hard on. It's how do you infer the type of data semantically? What is the meaning of a particular column? And on the basis of that meaning, what are the kinds of consequent operations that you should subject the data to, at least to try out and experiment? So I would say, yeah, pre-processing, we're getting there. There's a lot of work to be done. And if folks are listening, I think I would encourage them to continue to contribute to that, either like research or to that conversation. I'll say maybe a couple of other things just about the scale and the scope of this. I think that so far we've spoken about the algorithm selection, hyperparameter optimization, pre-processing, potentially imputation, data representation, feature selection. Oh, that's nice. What if you just keep climbing up, right? Like what else are data scientists expected to be doing? Well, what about feature discovery, right? Just like inventing new features. This is something that I find extremely exciting. It's like right now we assume that a data scientist had already prepared a data set with columns, right? With features that have some predictive elements to them. But what if we expected another model or another system to be doing that feature extraction in the first place for us, right? We see that a lot with deep learning today for various forms of meta learning, where you take an entire data set and you say, but give me some of the signature characteristics of that data set. So take the data set and embed it in some very large space, and then maybe find the distance between that data set and another completely different data set. What if we did that for databases, right? Or for data warehouses? What if you plugged in your database or your data warehouse and another system sort of like observed everything that you have, and you still had to, let's say, define what you want to be predicted. But then the system would say, if that's the case, maybe you should be looking at these features or those features. This should be a feature. That should be a feature. What if at some point AutoML can help us to generate features, if not feature ideas, right? So that's in the feature discovery. You can keep climbing up. You could just say, what about the problem framing in the first place, right? Should it be classification or regression? Perhaps it should be both. Perhaps for a subset of the data, it's best to solve it in this way and then feed the results into that model. But for this subset, it makes sense to do it in this way and then in that. What if the entire model topology was to be automated by the AutoML? So the space is massive. And I think the scope is close to endless. The scope, as I see it, is at some point to just blend in with automatic science.
Right. That was quite elaborate. Thanks for your response on that, Adam.
Yeah.
Do you have any question for me, Mrs. Sabine? Or should I go?
Yeah, we have a question that is a little bit more about team composition and roles. So Gustavo over on LinkedIn is asking, We frequently see one big role called data scientist, but regarding MLOps, Adam, do you have any suggestions for more narrow and defined roles of professionals?
Regarding MLOps, that's a very interesting question. The way that I see it now is we're going to have a realignment at some point soon about what the various operations are. Even like MLOps is, I believe, still incredibly broad. Data scientist is incredibly broad. And I think we're going to need to zoom in. The way I would think about zooming in is I would look at the various verbs. What are the actions that these roles tend to be associated with? Let's take, for example, a data scientist. What do data scientists do? What are the kinds of verbs that they engage in, right? They explore the data, they evaluate a model, they train, they tune, they validate, they split, they balance, all of these different verbs, I believe, are all going to go through some significant realignment, especially if the vision of AutoML is going to come to fruition. The question would be, we're still going to need to do those verbs. Those operations are going to have to take place, whether or not they'll be done by tools, whether they'll be done like automatically, or whether they will simply embed in other roles. So for example, nowadays, I believe that data scientists do a lot of evaluating, right? So let's say you have the model, is it working well? Is it not working well? To what extent is it working well? There's like a full on, you could just keep zooming into that. This is a massive space of opportunity to keep growing. I believe in the next few years, we'll see much more complex and nuanced views of evaluating ML models. But the question is, will that style of evaluation continue to reside under the data science umbrella? Or perhaps at that point, it will move towards the domain experts, right? I believe and hope that at some point it will move towards the domain experts. So the question is going to be, what are the different verbs? And depending on the different ideologies of different tools, how are those verbs going to, I believe that various roles will essentially annex different territories in the data science verb landscape and in the same way that's going to happen with MLOps, right? So what exactly are the operations that people undergo in MLOps? And will some of them just become commonplace software engineering practices? Or will some of them be subsumed by platforms or by tools or by the data scientists? Yeah, it's kind of hard to forecast these things, but I certainly wouldn't hang my hat on any role or title for any more than like 2 or 3 years.
Interesting. Thank you, Adam, and thank you, Gustavo, for the question.
Right. Thanks, Adam. And we have another question from the community, and this person is asking, I wanted to understand how useful AutoML packages like PyCaret are in an organizational setting. Do you use it frequently in your organization for day-to-day data science activities? If you have, what are the potential limitations you see with such packages?
That's an interesting question. I haven't used PyCaret, although I remember looking in the documentation and looking at the code at some point, and I think they had a very interesting time series module too. So yeah, we haven't been using them, but I think that it's the same limitations that you'd imagine with something like scikit-learn, right? Like, how does scikit-learn plug into your organization? Well, it's just an extra tool that would just give you an edge, right? So insofar as you don't have to be doing all of the pre-processing and the modeling yourself, you're not out there building new algorithms. You're just like using scikit-learn and seeing if that works for you. And if it doesn't work, just move on. So I think that I would probably see it in the same light. Again, PyCaret is not something that I would imagine people who haven't yet adopted the prediction paradigm using. It really is just an extra tool for data scientists. And insofar as that can accelerate your work, you should certainly try it out.
All right. Thanks, Adam. So this person is curious to hear your thoughts. AutoML and no-code tools, would you use them? If not data scientists, do you see somebody else in an organization who can benefit from them?
That's good. Okay. I think that really depends, who you are. As a data scientist, I think the question I would probably parse the question differently if you have a mature MLOps and data platform in your organization. If you already do, you might not want to adopt any of these other AutoML tools, especially like no-code and low-code tools. If you don't, maybe it makes sense for you to do that. If you're an analyst, if you come from the business function, if you haven't yet fully adopted the prediction paradigm, you don't even know what it means to have a predictive model, to even think in terms of finding the right columns, right? Those are excellent places to start. The extent to which you can then take those models and rely on those platforms to then power your applications, I think you'll have to kind of like do your own assessment about that. But if someone were to just come into the field and try to understand what columns should I even collect in the first place, I think those are excellent places to start, right? So like I speak to a lot of startups, and the pitch that they make to investors tends to just be like, oh, we're going to collect all of this data, and that data is very valuable. And ultimately, we're going to spin out a data science team, and we're going to really get a lot of mileage out of this data, right? We'll be able to build really good models. They are pretending that they know what kind of data is predictive, right? They don't have any data scientists on the team. Just adopt one of those tools to test whether or not you're right about this, right? Like you don't have to wait that long. You don't need to spin out a whole team. You don't have to get the data engineer, the ML engineer, the data scientist, the analyst to figure this out. Just use any of these tools to know whether or not there is a there, and whether or not it even makes sense for you to continue investing time and money into this. That's kind of my impression of it. Before you've adopted the prediction paradigm, these things make a lot of sense. Afterwards, it depends on who it is. If you're a data scientist, you may not want to use it. You might get marginal benefits aside from the MLOps abstractions. If you're a software developer, I think those tools are not yet targeting you. So you'll have to just sort of like wait for the product that we're building to get to the market.
Right. And I have a question on one of the questions I asked earlier, and that's sort of like unstructured problems. You talked about AutoML being like pretty good at you hinted about AutoML being pretty good at tabular data. And looking at a lot of unstructured use cases, how much of AutoML do you think covers them, like in terms of like the maturity, how it's gotten to that level? And also as a follow-up question to that as well, we are seeing a lot of, should I say, tools and emphasis being placed in the area of validating models, validating the performance of models and things around model evaluation and things like that. Case in point, the behavioral checklist a few years ago for NLP models, for example. Then how much of that do you see AutoML helping out in getting production ready models in place in terms of like model evaluation, but also solving these unstructured use cases to the point where we don't have to start going through them again. It's pretty much production ready or good to be put into like the production pipeline we're deploying with.
I think I got the evaluation part, that part of the question. The first part of the question, I don't think, at least in the research, that hadn't been focused on. So I would probably not, but I wouldn't imagine that that's nearly as mature as the structured case. You would probably need some other solutions there. Now, there's a lot of other things that are coming out. I think I saw some interesting solutions, some interesting products that came out of YC in the current batch to try to do AutoML-like solutions for unstructured data. So I know that this is coming, but I don't think it's nearly as big. But it really depends, I think, also on what you mean by unstructured here. So like support for language, for example, you have more and more solutions out there because very often you're just using existing kind of pre-trained models, right? Now, insofar as you just need pre-trained models and you just, let's say, take your text and do some form of embedding on it, that you already have AutoML solutions trying out. And they do that kind of automatically for you. I think Azure does that, if I remember right. You feed in a tabular data set, and some of the columns are text. They're going to take a subset of that, and they're going to say, well, let's try to add BERT encodings or the BERT embeddings for some of the text. And then you're going to try that out and see whether or not that gave you any predictive benefit. And if it does, then it's going to continue to do more and more of that. So some of that is already coming out of the box. You wouldn't even know that that's happening, right? You've just fed in the data. In other contexts, I'm not sure that AutoML would be the right solution, but there's already a lot of AI services that do that, right? So you need the image segmentation, fine, you just feed that in. This is not necessarily custom model. The moment you need to fine tune it, I think that's where you might have some more and more options, and that's where AutoML might come in, right? In order, again, to kind of like more efficiently travel through the space of options. So AutoML can then be useful in that way. And in neural architecture search, if you're really trying to do all of this from scratch. To the evaluation piece, I like that question because I think that the state of evaluation today is, in the machine learning world, is by and large abysmal. And I had on the podcast this Professor Jose Hernandez Arroyo, and he wrote for decades now on AI evaluation. And he made the point on the podcast that it's essentially what we have today in machine learning is nothing short of a scandal, basically. The fact that we are trained to optimize for a single metric, okay, what's the F1? What's the accuracy of this model? Is insane. If you like the moment that you actually like take some time to reflect on it. Let's imagine that I think the example that we gave there was like, if you have a self-driving car and it's scoring, 98% accuracy on the training set, and you really want to make it 99.9, however many % accurate. Well, that's easy. Just give it a bunch of easy examples and just like continue to test it on very easy examples, and now you'll just increase your accuracy, right? But that's not the point, right? The point is not how well it's performing on the test. The point is how well it's performing given various types of scenarios. How well are you performing when the fog is really bad? When the fog is really bad and it's snowing, when the fog is really bad and you're not having good visibility and it's dark, when the road is curvy and twisty, when you're driving really fast opposed to driving really slow. Those are the kinds of evaluation. We have to be evaluating the models much more on the basis of their capabilities as opposed to their performance on very specific tasks, right? So aggregating everything down into a single number, I think, is a disaster. And I think it's just like it's masking a much richer form of error analysis that we should make sure to subject every single model to. This is a lot to ask for from a single individual data scientist. A lot of that could and should be automated, right? If you're doing some kind of model on a particular, and a country code is one of the predictive columns there, you should out of the box already say, you're not performing very well when it's that country, or when it's that country and these are the kinds of other values that you tend to see in the data set. So that sense of very deep and rich evaluation would also be very useful during the modeling process. So AutoML solutions are very likely to stay ahead of this. So I see a lot of promise there in merging those worlds of model evaluation and AutoML.
Are there tools that you see are solving this particularly well right now?
Not that I could recommend.
Okay.
No.
Okay. Thanks.
And that's because I'm not necessarily very familiar with it, not because they don't do a good job.
Yeah. Yeah. Right. Thanks, Adam. So we have another question, and this person is saying AutoML is becoming something that even non-ML practitioners can use, develop and deploy entire MLOps process into production. What will be the role of ML engineers when organizations lean towards AutoML?
I don't know.
Right.
It's not clear to me. It's not clear whether they will transform into products, kind of like software developers, or whether they will go and work at AutoML platform companies, or we will find a world where there's room for lots of companies that have not yet adopted the prediction paradigm, have not yet adopted ML, to just like join the fray, and they will live side by side with companies that really need their own custom solutions for the long term, and they will need their own ML engineers. I don't know what's going to happen with them.
All right. Thanks, Adam. And then another question from the community, and this person is asking, any recommendations on platforms for AutoML for predictive analytics, NLP, computer vision, image analysis, platforms that are easier to use by businesses, non-technical folks, other than SageMaker, Google Vertex AI, AutoML, and Azure AutoML?
I really think that the AutoML space has not diversified its audience nearly enough. And this is the gap that I see in that market and why we've entered it. Because I think that right now they are still catering to data scientists for the most part. And I think that that's a challenge, because you really need more and more people in this conversation playing this game. Companies that already have data scientists have already adopted the paradigm. We need all the other companies. I would probably say it kind of depends on who the person is. Are they a data scientist? Are they a business person? Are they an analyst? Are they a software developer? Kind of depends on who they are. But by and large, yeah, I think that the answer would really depend on who they are and what they're looking for. It could also be interesting if at some point you start to see a proliferation of different types of AutoML platforms, ones that are very targeted. I've seen some interesting computer vision ops, like CV ops companies, and that some of them already offer a lot of support, kind of just for automatic model building or tuning and retraining and existing large computer vision models. I think that at some point it could also be very interesting to see if those begin to kind of verticalize, right? So do you have AutoML solutions for computer vision in medicine, what in medicine in particular, right? Like, so that you could just become more and more and more narrow. And I've seen a lot of papers come out, mostly for packages. I don't know about platforms, but mostly for packages that do somewhat verticalized AutoML solutions. So if you're looking for computer vision, and it depends what kind of computer vision, I would probably search for those things. And I probably wouldn't necessarily look for platforms yet. I might look for papers.
Right. And have you seen a particular platform that can solve most of these use cases? Like a platform that's really good at, say, like unstructured tabular data, and can also thrive well at, running architectural search for computer vision models or neural nets or things like that?
Not fully, but I will give a shout out to AutoGluon. I think AutoGluon has done a very good job, and they're out of Amazon, and their solution is open source. And yeah, I think it's been a fairly powerful team. They contribute a lot to the space, both in terms of research and just their academic contributions. And they do a lot of that. So they do like multimodal models and stuff like that. So you could do computer vision, you could do some images, you could do language, you could do tabular, and you can see all of their code.
Right. Yeah. Thanks for sharing that, Adam. And I would love us to circle back to when we started a particular podcast. Like you mentioned you had some reservations about companies adopting AutoML. Can we zoom into those reservations as of this time, and then why you recommend our companies actually push back against it right now?
Yeah, I think it really depends on the AutoML solution, and it depends on the state of the company. So if, for example, a company is already fully invested in spinning out a massive data team, it may or may not make sense for them to now introduce this tool, right? So like it wouldn't make sense to try to sell them on that tool. I think there's potentially a lot of benefits, but those benefits might be marginal. And I could see that those companies might push back against adopting those benefits because they're already implementing their own custom-made solutions, right? They have data scientists on board. Those data scientists are not just going to adopt machine learning AutoML quite yet. Is that a mistake from their perspective? I think in the long run, it's going to be a mistake. But I could see why in the short term, the benefits might not kind of outweigh the costs. In the long term, I don't know if folks are familiar with the bitter lesson. So this, I think like Richard Sutton wrote this article, The Bitter Lesson. The bitter lesson, he says, of just the last 70 years of AI research is that given enough computation, those methods that leverage computation tend to outdo methods that use and leverage human creativity, right? So like, for example, like when AI first beat Garry Kasparov in chess, right? People were up in arms and so, yeah, but it was just using a very deep search, right? It was just searching through a lot of options, so that's why it won, right? So like people were just like genuinely very skeptical. Right now, methods that leverage search are commonplace, right? But this is what's happened in chess. That's in all these, by the way, all of these critics had first said, well, it's just doing search. Why don't we try to really embed all of the knowledge that experts have about chess into the program, right? Let's try to pull in the humans and design a program that does an even better job than pure search. That tended not to have worked very well. If you're just relying on computation and search, you're good. Same thing happened with computer vision, right? Like in the 80s and the 90s, if you wanted to detect cat ears, you would then pull in the expert, right? The cat ear expert to try to tell you what is the kind of geometry that is unique to the cat ear. And then you could, okay, at some point we said, this is all nonsense. This is not gonna work. Just give it more computation, give it more data, allow the AI to do more and be more. And now it obviously beats anything we've done in the 80s and 90s. This is the trend, right? The bitter lesson is that we are just so invested in maintaining the centrality of the human that we're not going to allow the AI to do more and be more. And I imagine that this is going to be some form of resistance from a lot of companies that really want to make sure to get the most out of their existing investments in humans. And those humans don't want to be replaced by even better AutoML solutions. So they're going to push back. And in the short term, they might be right to push back. That's the reservation. It might seem like, no, if you just allow the other chess expert to give you an extra idea, maybe you would improve your chess AI. But in the long term, they're not going to be right. So that's kind of the structure of the reservation.
Awesome. Perfect. Thanks, Adam. And if there are no questions from the community, my ending question will sort of be AutoML versus data scientists or AutoML and data scientists. Which one do you see? Which one is the trend going towards in terms of like the technology adoption as well as the maturity of the technology? And would you say most data scientists moving towards the MLOps sphere as more and more of the modeling angle as well as the pre-production angles are being automated?
I think it's going to go in both ways. I think we're going to see movement from data science to more of the MLOps, more of the engineering a little bit. And if our company succeeds, we're going to see more software developers handling the model building automatically. So I think that you're going to see simply more hands touching the modeling. Yeah, so I think that whatever is involved with modeling right now, I believe will be carved out and embedded and blended into various more roles. So I think that we're just going to see a fragmentation of roles. So yeah, it's hard to even forecast what the role of a data scientist would be in, let's say, like 5 years. It's not clear whether they would be mostly evaluating or simply designing training data sets or doing quality checks on AutoML models or just doing other MLOps stuff, or whether almost all of the modeling will be done by automatic systems and software developers will be the ones directing those systems.
Yeah, we've tried to keep a lot of the conversations on today's reality, but yeah, definitely when talking about AutoML, because of the space, it's hard not to talk about what we prospect. So thanks, Adam, for that.
Yeah.
All right, so we are nearing the end here, but to wrap things up here, Adam, what would you say is the biggest challenge with MLOps right now from your perspective? Is it like dismantling the pushback against AutoML, or is it something else?
The biggest challenge, well, I can tell you some of the challenges that we're facing kind of internally and stuff that we're working on. I think that it might be, so yeah, I think it's more of like an architecture and like a software design question. It might be, I think it falls into MLOps too, but the moment that it isn't the model at the center, but let's say it's like a full pipeline or it's a full workflow, right? Or it's a sequence of models that are tied to a particular way of organizing the data. If you have this kind of new creature as like the first class citizen, what other abstractions have to kind of orient around that conception? So if you need to design various services, what's the proper way of handling that entity? To what extent should that entity contain only state or state and some behavior? And should we have various services embedded? These are kind of like more of like software design questions that I think with a broader scope of what the model is and should be doing, you have to kind of reconsider a few other elements that other companies might be holding static. And we're kind of like in that mindset.
All right, awesome. So before we wrap things up, Adam, you are probably in the MLOps community Slack, am I right? Where people can get in touch with you. But is there any other way that people can sort of follow what you're doing online?
Slack is great. My email is adam@telepath.io, and my Twitter is at Adam Boaz Becker, B-O-A-Z Becker. I'm pretty sure that's it. And if you want to listen to the AutoML podcast, if you want to understand what is happening on the front lines of this research, so I interview weekly researchers and practitioners, folks engineering AutoML systems, and then what's happening, and then also other spaces that I imagine are very soon to be impacted by AutoML. So that's the AutoML podcast.
Great. Well, thanks for coming on and shedding some light into the vastness of the AutoML landscape for us. Thanks, Adam.
Thank you for having me. This was really fun.
Cool. So we'll be back in 2 weeks, as always, on the 13th of September. Once again, Tuesdays instead of Wednesdays nowadays, and 1 hour earlier, so 5 p.m. Central European Summer Time, same time as today, but 1 hour earlier than it was initially. And next time we'll have with us Duarte Carmo, and we will be talking about MLOps at a small scale, how early stage startups and small teams tackle MLOps. So in the meantime, we'll see you on socials and in the MLOps community Slack, As always, you can submit questions in advance if you cannot make it, and also talk to us afterwards about anything MLOps related. And of course, you can then catch up with the episodes later, wherever you get your podcasts. So thanks again to everyone, and see you next time. Take care. MLOps Live is brought to you by Neptune.ai. Remember that you can join us live at the next event and ask your questions. And you can register at neptune.ai/events.
And then make sure to search for MLOps Live in Apple Podcasts, Spotify, Google Podcasts, and anywhere you get your podcast. Click follow and don't miss any episodes.
Thanks, and see you next time.